two ways I can reach Goa by using the route number 1, and for different 4 and 5 routes from Mumbai to Goa. Similarly, if I use route number 2 and route number 4, again we use route number 2 and route number 5. Again, there are two ways that we can reach to Goa. Similarly, if I use route number 3 from Delhi to Mumbai and the route number 4 for Mumbai to Goa, and route number 3 and route number 4, and it comes out to be 2 again. So if we count it out, the total number of ways I can reach Goa from Delhi via Mumbai, this is 1, 2, 3, 4, 5 and 6. There are 6 routes. So what I mean to say, what I want to say, that is that there is a direct correlation between the mathematics and the language. And the answer of this mathematical problem, which is written in a language, comes out to be 6. So there must be some language of the mathematics as well. And what is the language of the mathematics? And that how it can be understood from the language. Let's see that thing. See, the total number of routes coming out to be 6. Now, if I write this thing, again I can have an answer as a 6. But how that answer is coming out to be 6? See, I have 3 choices from Delhi to Mumbai, and I have 2 choices from Mumbai to Goa. So using 3 and 2 and using one single operation, how can I get 6? Means I repeat it again, from Delhi to Mumbai I have 3 choices, and from Mumbai to Goa we have 2 choices. So using a single mathematical operation, the number of ways we can have means the number 6 can be obtained. The number 6 can be obtained by using 3 and 2. Is that very simple answer, that is 3 into 2 has to be 6. So it makes the sense that whenever I will be getting add, or rather we will be getting and, the mathematical meaning of that and is multiplication. And wherever we will be getting or, the mathematical meaning of that or is plus. Because again we say, let's say if I want to elaborate this 1 and 4 and 1 and 5 in our language, we say from Delhi to Mumbai I'm using route number 1, and from Mumbai to Goa I'm using route number 4. So this is the one way to reach Goa from Delhi via Mumbai. Or I will be using route number 1 and route number 5 from Mumbai to Goa, because this combination is different altogether from 1 and 4. So that is a one choice and that one choice. So actually it is a one choice we are writing. This is a one choice. Similarly, we have again one choice. There is again one choice, one choice, one choice, one choice. So how many choices we have? So you are writing 1. This is a one choice, this is a one counting, this is a one counting, this is another one counting, one counting, one counting, and this is another one counting. Now you have to use 1 6 times. And how can you get 6 using 1 6 times? A simple arithmetic exercise, that is 1 plus 1 plus 1 plus 1 plus 1, that is 6. So why we are using plus here, right here, reason being it comes out to be the language in the language we say we are getting as a or, and in different means 3 into 2, that is we are getting 6. So the problem is, wherever you will be getting, means the basic concept which comes out to be from this exercise, that whenever in mathematics you will be getting and, You will, in the mathematical sense of that and is multiplication, and this whatever you will be getting, or the mathematical sense of that or is addition. So this is the very first concept you can say we will be using. So in any mathematical problem which is written in language and it sounds anywhere, it sounds and. So that and means, that and implies that is multiplication, and wherever you get or, that means is addition. So using this there is one concept which I just told you, that is the fundamental principle of counting. So coming out to be that fundamental principle of counting, let's say you can exercise one event via m ways, means you have m option to exercise one event, and another event can be exercised via n ways. One event we can exercise via m ways, and another event via can be exercised via n ways, and there is no direct relationship between these m and n. If you see this, no matter which route you use from Delhi to Mumbai, your further journey, that is from Mumbai to Goa, will not be affected from your previous journey. Means these two events we can say are independent, or there is no direct correlationship between these two events. So if you are performing one event via m ways and another event via n ways, and you ask the number of ways in which these two events can be exercised. So I'm performing the first event via m ways, and I'm performing the and means into multiplication, another event via n ways. So the total number of ways we can perform these two events via m into n ways. Clear? And suppose you are asked the number of ways you can perform any one of the event. Means either is the event number 1 or event number 2. So any one of the event can be performed via m. I will be performing either event 1 or event 2. So when it comes out to be or, that it has to be plus. That means m plus n ways we can perform any one of the event. If we are performing both the events, first we can perform the event number 1 via m ways, and another event we are performing via n ways. So the total number of ways we can perform these two events is, first we are performing via m ways, and we are performing the second event via n ways. So m into n is equals to mn. While if we are asked find the number of, if you are asked find the number of ways you can perform a single event, that is either you will be performing m means first event, or you will be performing second event, that is n ways. So this is what the fundamental principle of counting is. Let's say we have 7 batsmen and we have 5 bowlers for a selection. And you are asked the number of ways you can select, the number of ways you can include one batsman and one bowler. You are asked the number of ways you can select 7 batsmen and 1 bowler. Obviously, you will be selecting a batsman. There is no humor involved that we will not be selecting any all-rounder. We are specific about right now. That's the batsman and the bowler. So, the number of ways we can select a single batsman. Obviously, we have 7 choices we can make. Batsman number 1, 2, 3, 4, 5, 6, 7. So, we have 7 choices. So, the batsman number 1 we can use via, we have 7 ways, and for bowler we have 5 choices. So, the number of choices coming out to be 7 into 5, that is equals to 35. So, these are the number of ways we can select 30, the number of ways are coming out to be 35, means the number of ways we can select one batsman and one bowler out of 7 batsmen and 5 bowlers, that is 7 into 5 is equals to 35. And if you're asked the number of ways we can select a batsman, suppose you're asked the number of ways you can select a player out of 7 batsmen and 5 bowlers. So now we have to choose a single player. So we have 7 choices. So either we can select a bowler or we can select a batsman. So for first, means for batsman we have, if I am selecting a batsman, I have 7 choices, or I will be selecting a bowler, and for bowlers we have 5 choices. So the total number of choices 7 plus 5, that is equal to 12. So these are the number of ways you can select a player out of these 7 batsmen and 5 bowlers. And if you have to select one batsman and one bowler, that is 7 into 5, that is 35. And there are so many other problems we can generate, and there are so many other problems. These can directly be solved from this fundamental principle of counting. Suppose you have suppose there are 3 questions A, B, C, and these 3 A, B, C questions are objective type questions, and question number A have 4 choices, means there are 4 options are there, 1, 2, 3, 4. And question number B, again we have 4 choices. Question number C, again we have 4 choices. And you are asked the number of ways a student can answer these 3 questions. So always read this permutation combination problem very carefully. Now you are asked the number of ways you can, means a student can answer these 3 questions. See, and it is must to answer these 3 right now, means that what we are taking. So for the question number A, we have 4 choices, and for question number B, we have 4 choices, and for question number C, we have 4 choices. So that is 4 into 4 into 4, that is There are 64 ways we can solve, and a student can answer these A, B, C, these three questions. See, see, this problem can be asked differently. Means